Hello, class. We have another aspect of stereochemistry to consider, and it pertains to the configuration of the carbon atoms from the diene relative to those from the dienophile. And so those relationships, we have two types. We have what's called the exo product and the endo product. And so what you need to be aware of is how to tell them apart. Okay, and you can see things are highlighted here. That if the electron donating groups on the dienophile are on the same side of the ring as this carbon right here, then we have the exo. And if they're on opposite sides of the ring, we have endo. Now let's generalize this a little bit more. Recall when we looked at the dienophile, we have the hydrogen atoms here. Okay. And recall from previous video, if we look at the dienophile like a cave, we have the outside groups right here, and we have the inside groups. Now, from that perspective, we can say, hey, that is the inside of the cave. Okay, and what is the relationship? If the substituents on the dienophile are on the same side, then they're exo. And here you see that is also the inside, and that those groups are on opposite sides of one another. Okay? Now, where would these hydrogens be? Well, they're going to be right there. Okay? So that's another way of looking at it. When you're looking at the Diels-Alder product, you're just looking at those groups and where they are with respect to the inside on the diene. Okay. Now you can also see that the endo product is the favored product. Another key piece of information that you need to remember. Now, we will delve deeper into the reason behind the endo is the major product later, but we're just putting it out there. Got to make sure you understand that. Endo, more stable, or the prominent, this product dominates, okay, when we do these reactions. Now, let's take a look at the endo. How do endo products form versus exo products? And it all has to do with the approach of the dienophile. So in a endo approach, do you see how the electron withdrawing groups on the dienophile are underneath the diene? Right? So as that approaches, the electron withdrawing groups right here are approaching the diene. Get my laser there. So when this bond forms, we see with these arrows here that as these carbons go from sp2 hybridized to sp3, that the inside group and the electron donating group on the dienophile are on opposite sides of the ring. So based off of the approach, the endo approach is going to give us our endo product. And I want to take this molecule here and draw it this way so you can see it in a different way. So we're forming our six-membered ring here. Let me get something here. Right. Let's draw this and then that. Okay, I'm going to draw those as wedges. Okay, so this carbon right here Or better yet, this carbon right there is that carbon right there, right? Or that one. And this is the endo product. So that means that the CO2 CH3s are going to be dashes. Because when we look at it in like this chair looking thing, you see how they're on opposite sides. And then when you look at it in this view, that carbon and those groups are on opposite sides of the ring. One's a wedge, one's a dash. Okay, that's really important to be able to see that. So when we do reactions, I would expect you to look at that molecule. If that's all you had, just looking at that molecule, would you be able to tell me that that is the endo product? All right. And the trick is, look at the electron withdrawing groups that came from the dienophile, and where are they with respect to the inside carbon or the inside groups of the dienophile? Of the diene. I am so sorry, I'm mixing that all up. This right there is the diene. That is the dienophile. Okay. So let's take a look at the exo product. All about approach. Now do you see how the approach of those electron withdrawing groups are pointing away from the diene? When you look at the transition state, you can see that the groups are not underneath the ring. Let's compare that. See how they're under the ring and not under the ring. Okay. And then when these bonds rehybridize to sp3, you can see that this group right there, the inside group, and the electron withdrawing groups from the dienophile are on the same side. So if we redraw this, we would see something that looks like this. Draw those as wedges, and then these would be wedges as well. And that would be the exo product. And you know that's the exo product because the electron donating groups from the dienophile are on the same side as the inside groups on the diene. Okay? So in class, we are going to delve a little bit deeper into why. What are the reasons behind the endo-exo? Why is the endo favored? Why is the exo not? And we'll delve more into that. Okay, so if you understand this coming into class, you guys will do great.